Welcome to another informative video on electrical motors. In today's video, we will be looking at brushless motors in general. The way these motors are designed will be looked at in detail, and their application in an industrial setting. Stay tuned. Brushless motor can also be known as an electronically commutated motor or as a synchronous DC motor. This motor works on direct current supply. Brushless motors are made of the following part, which are the stator, rotor, and the sensor.
The electronically commutated you called earlier sounds so technical. On a lighter mode, the electronically commutation means moving the applied current from one coil to another coil as the motor rotates via electronic means. This action was what birthed the name electronically commutated motor.
Perfect, Laura. The plan is to energize multiple windings simultaneously as the rotor rotates without interrupting the rotor axial rotation. So let me say that I am not surprised by the name. Perfect.
On the construction side, a brushless motor is similar to a permanent magnet synchronous motor or as an induction motor.
That should depend on how you are looking at it. But their mode of operation is sure going to be different.
Sure. Now, unlike the other motors where the rotor is the moving part. However, in a brushless motor, reverse is the case. The stator, which is where the permanent magnet is, will now act as the part that rotates when the motor is powered on. This permanent magnet is made of neodymium material.
Of course, since the electromagnet is on the stationary parts, there won't be any need for brushes, because the connected terminal will not move along during rotation. Hence the reason why it is called a brushless motor. Perfect.
So basically, this motor comes in two forms, which are in runners and outrunners. In outrunners form, the rotating permanent magnets usually surround the coils, but reverse is the case for the in-runners types. In runner motors, the coils surround the rotating permanent magnets.
You know, just like I said earlier, the design of this motor is going to be a little bit different from the other motors we have in the market today. At the end of the day, the designer simply capitalized on the fact that electromagnets can generate a magnetic field of different poles, and when arranged in a special way, then magnetic torque can be induced on a medium. And the most common medium we have today are metals.
Now that we have known the parts and the type, let's look at how this motor works. Now, when the winding is energized with a DC source, the permanent magnets will naturally align themselves with the electromagnets, and it will stop.
Of course, this force is due to attraction and repulsion that occurs when handling magnetic material. In our case here, we are dealing with electromagnets that induce different poles.
Perfect, Laura. That should be known as like and unlike force.
Now, based on the location of the electromagnet, and looking at this graph here, the axial displacement that just occurs is 90 degrees and it stops. The reason why it stopped is because the permanent magnet has aligned itself with the generated poles of the electromagnet of opposite field, and there is no external force acting on the magnets.
Because there are no external force acting on the pair of the moving magnets, The rotating magnet will stop and everybody will be fine. Perfect.
Now, in order for us to make the motor to rotate at some additional degrees, then there is need to add more electromagnet.
Perfect. The added electromagnet will attract the freely moving permanence magnet towards itself.
Of course it will pull the magnets if some condition are set and it is right.
Yes, you are right. We will need to move the applied current to the next winding. And the polarities of the applied current must be the same from where it was formerly disconnected. This same configuration ensures that the magnet continue to move at the same direction. Otherwise, the magnet might rotate the other way round.
The added windings will cause the magnet to rotate to the next electromagnetic.
Now, when we change the energized electromagnetic circuit at intervals, the magnet will continue to rotate. And the component used for switching of these energized circuit is an electronic device known as Hall effect sensor.
So basically, the rotating magnet will be chasing the magnetic field. But because the field is always changing as the permanent magnet moves from one electromagnet to another, it will not be able to catch up with a moving magnet. And as such, torque will be generated. Perfect.
Now this process is known as commutating, which is switching the energized circuit via Hall effect sensor. However, in order to have a motor that will deliver a far greater torque, then there is need to manipulate the winding of the motor in another form. Now because the next winding is of the same polarities, let's connect all the winding to the same power polarities. When connected, and when the motor rotates, we notice that one of the winding is giving a negative torque. Now the winding that is giving the negative torque will be switch off while others will be switch on. So when the moving magnet has almost gotten to the red windings, we will flip the polarities and turn it on. Again the negative torque has now moved to the blue windings. Now we will turn off the windings. And the next winding will be energized.
The reason why we have this negative torque is because the current is 120 degrees apart.
Switching off the winding and flipping the polarities fix the negative torque. Otherwise, the rotating magnet will suddenly stop, which is because the windings with the negative torque would impede the axial rotation of the permanent magnets.
Now in order to have a perfect motor, let's connect all the other end of the windings to a loop. The remaining other ends of the windings will be connected to a switching device. In our case here, we are using a Hall effect sensor. This sensor switches when there is a change in magnetic field.
So as the moving magnet rotate, the Hall effect sensor will detect the varying magnetic fields. And it will switches accordingly.
That is it on brushless motor. If there are any area of doubt, kindly leave a comment in the description box below. In the coming series, we will be looking at servo motors. The part that made up a typical servo motor will be looked at, and their application in an industrial setting. Hope you have learned something new today. See you at the next one.